Hello and welcome back to Bioclass Bites. In this video, we are going to talk about volcanism and earthquake. Don't forget to subscribe to my channel and like and share this video. These are the unit and lesson titles for this video series, and in this video, we are going to focus on volcanism and earthquake. So, volcanism and earthquakes are under sudden movements, and they are one of the two endogenic processes that we have. So the sudden forces are the result of long period of preparation deep within the earth. So even if volcanic eruptions and earthquakes seem to happen suddenly, they are results of long period of preparation deep within the earth's layers. Geologically speaking, these are considered constructive forces from the perspective of the earth landforms because they create certain relief or features on the Earth's surface. So again, volcanic eruptions and earthquake may seem to be sudden in terms of their occurrence, but they are products of long period of preparation, and they're considered constructive forces even if they destroy buildings and they destroy landscapes. They're considered constructive because they create relief features on the Earth's surface. Sudden movements could become disastrous, especially if they occur in densely populated um, areas. So movements are caused by endogenic forces coming from deep within the Earth, and they may cause rapid and sudden events on the Earth's surface. So again, I want to emphasize this. Volcanism and earthquakes are results of long period of preparation. Only their effects are considered quick and sudden. So let's look first at volcanism. A volcano is an opening in the Earth's crust through which gases, molten rock materials, such we call it lava, ash, steam, and others are emitted outward in the course of an eruption. Okay, so we see here an anatomy of a volcano. So we all know that if the molten rock is found deep beneath the Earth's surface, we call it magma, and then we have the magma chamber here. And then the throat or conduit of the volcano is where the magma could pass through as it goes out in the form of volcanic eruption. Now, once that magma reaches the surface and starts to flow out of the vents, out of the craters, um, now we call the molten rock as lava. Now, aside from the molten rock, volcanoes also erupt with gases, okay, ash, steam, and other pyroclastic materials. So such vents or opening occur in those parts of the Earth's crust where the rock layer or strata is relatively weak. So volcanism includes the movement of molten rock. So that's still magma when it's still under the earth, out towards the earth's surface. Okay, and this could result into intrusive or extrusive volcanic forms. If you could still remember our lesson on categories of rocks, we also have intrusive and extrusive igneous rocks as results of volcanic activities. So a volcano is formed when a molten magma um, escapes through the crust or vents, crust or vents, okay, crust or vents, um, accompanied by steam or gases. So those gases are hydrogen sulfide, sulfur dioxide, hydrogen chloride, carbon dioxide, and pyroclastic materials. So when we say pyroclastic, these are rock fragments or ash erupted by a volcano. So when we say it's a pyroclastic eruption, usually the eruption would contain rock fragments and ashes. So here we have examples of some volcanic activities. So this is Cleveland volcano and in the Aleutian Islands of Alaska, Stromboli volcano of the coast of Sicily. It has been continuously erupting pyroclastic materials for thousands of years, and these are ash plumes. Okay, again, pyroclastic eruption from Mount Pinatubo in 1991. So I recommend that you watch this video entitled Most Incredible Volcano Expedition Ever 2012. I will provide the link in the description below. This one is a geography lesson. What is a volcano? I will provide the link in the description below. So just to clarify the difference between magma and lava. So magma refers to molten rocks that are still found inside the earth. Okay, they are under the earth. They are found in the mantle, or sometimes they could make their way towards the asthenosphere, towards the lithosphere. But as long as they're still within the earth, we call it magma. However, once magma comes out of the surface through a volcanic eruption, through the vent of a volcano, or through the crust of a volcano, it's now called lava. Okay, so there's really not much difference except of their location. So molten rock underneath the earth, we call it magma. Molten rock on the earth's surface, we call it lava. Okay, so this is a lava flow happening in Hawaii. So another description, another comparison, magma is an intrusive material. It's found underneath the earth. Lava is an extrusive material found on the earth's surface. This video is from natgeotv.com. I recommend that you watch this. Volcano lava. I will provide the link in the description below. This one is also from National Geographic. Drone sacrifice for a spectacular volcano video. Again, I will provide the link in the description below. Now, this is really not part of our lesson, but I would just like to present to you that there are several types of volcanoes. So, if there's really no peak or a mountainous structure, but there's lava coming out of an opening, we call it a fissure volcano. So, there's just an opening on the ground. We call that a fissure volcano. If there's this a cone-like structure, a mountain-like structure, and then there's a lava flow coming from the magma chamber. We call it a shield volcano. If it is a volcano with several openings on its side, we call that a composite volcano, several vents. And if it is a caldera if if it has its own shield, and then from within, that's where the magma could bubble up. So these are further classifications of volcanoes. So we have classification based on frequency of eruption. Active volcanoes are those who are active or are frequently erupting. Dormant, they have not erupted at least once in human history. And extinct volcanoes, they have not erupted at all. In terms of mode of eruption, so center type, so they have a conical form. Yeah, conical form wherein lava could erupt or lava could come out. A fissure type, this is this one. Yeah, there's an opening on the ground, no cone shape, no mountain structure. So just a fissure on the ground. Then based on the characteristics of lava, so we have volcanoes that erupt basic lava. So the lava will be rich in metallic minerals and has a low melting point. They usually form shield volcanoes. So the lava is basic in its characteristic. Volcanoes could also have acidic lava, so rich in silica, and they have high melting point. So usually they are found in composite volcanoes. Now this map shows us the major volcanoes of our planet. So as you can see, we have quite a lot along the Pacific region. So it's called the Pacific Ring of Fire. And the Philippines is somewhere here. You see here Mount Pinatubo and Mount Mayon. Then we have the rest of the active volcanoes along this Ring of Fire. Okay. And if you still remember our lesson on the Earth's energy, along this volcanic rings is where the Earth loses most of its heat energy. Okay, and if you still remember our lesson on seafloor spreading, this is also where most of the new oceanic crusts are formed. Okay, most of these underwater volcanoes. Now this one is also another map, but this time it shows us the location of all earthquakes recorded by seismographs since 1898. Okay, so you see here the glowing dots, okay, and it runs parallel with the rings of fire, the volcanic ring of fire in the Pacific. Okay, so that this is where also most of the earthquakes occur. So that's where most of the plate boundaries are found. Okay, so by far the largest and most frequent earthquakes occur at the convergent plate boundaries around the eastern, northern, and western margins of the Pacific Ocean. Okay? So how about the volcanic activities in the Philippines? So if you still remember, the Philippines is found along a region that has a lot of triple junction plate boundary interaction. So aside from that, we are also found along the Pacific Ring of Fire. Okay, so we have a lot of volcanic activities here. So the reason why we are like that is because our country is actually squeezed between two convergent plate margins, and um, we have several active volcanoes found on corresponding volcanic arcs. So we have here in Luzon volcanic arcs and Mindanao volcanic arcs. So these are the reasons why we have such many volcanoes. So we are at the junction of the Philippines tectonic plate, Eurasian plate, and those are, of course, the boundaries of those are actually sites of volcanic activities. So there are 53 active volcanoes in our country, and because of that, we belong to the Pacific Ring of Fire, where the oceanic Philippine plate are subducting along the Philippine Trench to the east, and the Luzon and Sulu to other small trenches to the west. So I recommend that you visit this website. I will provide the link in the description below. So Mount Pinatubo eruption in the 1990s is actually one of the most devastating um, volcanic eruption in human history, and most of us are actually only know about it on books or on videos, but most of our parents and our grandparents may have some memories about it. But if you're interested, I recommend that you watch this video. I'll provide the link in the description below. So, the volcanoes of the Philippines rank as the most deadly and costly in the world. Okay, so we are number one in that aspect because 30% of our historic eruptions and 22% of its eruption has caused significant damage. So aside from the volcanic destruction, we also have lahar. Those are mud flows. So that happens when it rains right after a volcanic eruption. Then tsunamis could also accompany our volcanic eruptions. Because of that, PhilVox, the Philippine Institute of Volcanology and Seismology, um, was um, was created in order to study our 53 volcanoes and to help notify the citizens of such impending eruptions. So this is actually a news article about the Taal volcano just this January. I hope you still remember that. So if you want, you could check out this website. I'll provide the link in the description below. Now this video is from GMA News. So this video tries to explain why there are so many volcanoes in the Philippines following the Taal eruption last January. So here are some of the active volcanoes in the Philippines. So we have Mount Mayon volcano, the Mount Taal volcano in Batangas, Canlaon, Musuan, Pinatubo in Zambales. So these are just a few, Hibok-Hibok and Camiguin. These are just few of our 53 active volcanoes. So I've mentioned this in our discussion about categories of rocks, but for you to remember, igneous rocks are actually formed from volcanic activities. So if the lava cooled above the Earth's surface, or if it's already a lava, of course it's on the Earth's surface, and it cooled, they become extrusive igneous rocks. But if the magma cooled underneath the Earth, we call it intrusive igneous rocks. So these are examples of those specific examples of those rocks. So I've mentioned this, that the Philippines is part of the Circum-Pacific Belt or the Pacific Ring of Fire. So along this region is where a lot of volcanic activities happen, and this is our country here. Okay, so that's why we have such many active volcanoes. This website is from National Geographic. National Geographic. These are a lot of more information about volcanoes and recent volcanic eruptions. So I'll provide the link in the description below. This one is from Smithsonian Institute. National Museum of Natural History, more about volcanoes. Again, I'll provide the link in the description below. So just to clarify, these are the words that that we've been repeatedly using. So magmatism refers to the formation of igneous rocks from magma. So this happens underneath the earth. Okay? So magmas form by partial melting of rocks. So we've talked about this in the rock cycle, and also we have established this in the plate tectonics. So magmatism is the formation of igneous rocks underneath the Earth's surface, and it is responsible for mountain formation. We've talked about this on orogeny. Volcanism is the eruption of magma on the Earth's surface. So if it happens underneath the Earth, it's magmatism. But if the molten magma happens to erupt on the surface of the Earth, we call that volcanism. So it could have pyroclastics, so those are ashes, and steam and dust clouds, or volcanic gas eruption. So volcanism includes the phenomena resulting into the eruption of magma onto the Earth's surface. So again, just to clarify, magmatism starts from the mantle, okay, a stenosphere, and then until it reaches the lithosphere, right, just below the Earth's crust. So that's magmatism. Melting of magma, rising of magma, intrusion of magma, then preparing to erupt. However, as soon as it reaches the surface and erupted out of a volcano, then we call that volcanism. So it includes the troposphere and the stratosphere, already part of the atmosphere. So magmatism happens underneath the Earth's surface. Volcanism happens above the Earth's surface. The next type of sudden movements are earthquakes, and usually volcanic eruptions are accompanied by earthquakes. So an earthquake is the perceptible, okay, the observable shaking of the Earth's surface resulting from the sudden release of energy from the Earth's crust, creating seismic waves. So these are the parts of an earthquake. The focus, that's the point, the actual point on the plate, the actual site of release of energy, while epicenter is the point above the ground on which the earthquake is felt. So earthquake is a seismic event that generates seismic waves, and this is mostly caused by the rupture of geologic faults or the release of energy from the tension from geologic faults. Earthquakes are among the most deadly natural hazards. There are around 100 earthquakes each year, and similar to volcanic eruptions, they are considered deadly and catastrophic if they happen to occur at densely populated areas. So here are some of the notable earthquakes in the Philippines. So this is the before and after the Bohol earthquake of 2013. So this was the Loon Church before the earthquake, and this is how it appeared after the earthquake. So this one is caused by a tsunami in Mindanao, Moro Gulf in 1976, and this is what happened to Manila Cathedral after a destructive earthquake in 1880. So this video will actually explain to you further the different parts of an earthquake, but just to recap, so the focus is that actual site wherein there's a geological tension, geological fault. Okay, so focus. This is found underneath the earth. However, once the plates snap or once the energy is released, it will be felt above the ground where the people are, and we call that the epicenter. So focus underneath the earth. Mostly this is caused by the action or by the tension of the tectonic plates. But once the energy is released, it will be felt above the ground. That we call that epicenter. So I'll provide the link in the description below. These are fact or fictions about earthquakes. This is from U.S. Geological Society. I will provide the link in the description below. I recommend that you read this. This is from the British Geological Survey. Still more about earthquakes. Again, links in the description below. So again, focus of an earthquake is always underground. This is where the slipping, sliding, and crashing of the tectonic plates happen. Okay, so for example, this is where the tension is happening, where the plates are grinding against each other. But once the energy is released, once they snap, they they are once they snap or the energy is released, it will the seismic waves will travel um, from in all directions and upward. It will be felt by us humans and by animals, and then we call that the epicenter. So if you still remember, fault mountains are actually sites of frequent sites of earthquakes because it suggests that there's a tension among the plates happening in that area. So now this shows us what could happen if that earthquake, okay, happens underwater. Okay, so that's what we call tsunami. Okay, so tsunami is generated by the displacement of the ocean floor. Okay, so this release of tension between plates could generate huge amounts of energy in the bodies of water, and that bodies of water will eventually travel. Okay, the energy on those bodies of water will travel towards the land. Okay, so in the form of waves. Okay, so um, waves moving in deep water, okay, advance at speeds of 800 kilometers per hour. Okay, so quite fast. But as it moves in shallower waters, as the depth decreases and as it nears uh, the beach or the land, okay, the speed decreases. Okay, but still it's quite dangerous if you happen to live near the sea or the ocean. Okay, now this one is an image, actual photo of the tsunami generated off the coast of Sumatra in 2004. Okay, um, you can see it's quite frightening, no, to see these large waves coming towards the beach. So the first thing to do is to leave and evacuate the bridge as soon as you see the water receding. Right, receding. So it's going backwards. It means that a larger wave will come next. Okay, so Japan is quite, is known for its very violent tsunami events. Okay, so the most powerful earthquake to strike Japan was the 2011 Tohoku earthquake. Okay, this was quite a historic event that resulted in around 15,000 deaths. Okay, so not only was Japan damaged by the actual earthquake, it was also damaged by the devastating tsunami that followed after. Another devastating effect of earthquakes would be fires. Okay, so we see here San Francisco in flames following the 1906 earthquake. Okay, when broken water mains left firefighters without water. Okay, so the firefighters did not have water to extinguish the flame. Okay, that's why it became bigger. The fire became bigger and bigger. And another thing, fire was triggered when a gas line. So that's an under it's a pipeline underneath the Earth's surface ruptured during the 1994 North Ridge earthquake. So not only are we susceptible to tsunamis if we are near bodies of water, fires can also happen after an earthquake in major cities. This is again is from USGS, US Geological Society. More frequently asked questions about faults. I'll provide the link in the description below. So these are examples of those faults. Um, so it can have a strike-slip fault, wherein the two blocks or the two plates slide past one another. Example would be the San Andreas fault. Normal fault, one is dipping slowly, dipping downwards, then the other. Then thrust fault, the other block is being pushed upwards. Okay, so examples: San Andreas fault in the U.S. This one, Basin Range. So you have the horse and the graben here. And then the Himalayas, we all know that's a result of the collision of the plates. So we all know that. Now this is actually, the Quakes is actually a real-time website that shows us the earthquakes happening at the moment. So if you're interested, you could check this out. I'll provide the link in the description below. Now, this is actually a playlist of the deadliest earthquakes on Mother Earth. So they cut it into 4 videos. If you're interested to watch, I will provide the links in the description below. So these are news clippings from GMA, particularly the recent Cebu earthquake. So you can watch this video. I'll provide the link in the description below. This is a coverage of the Bohol earthquake that followed right after. Again, linked in the description below. And then this is what the Metro Manila cities are preparing for, the big one. The possible damage that could arise once the West Valley Fault moves. Okay, so again, I'll provide the link in the description below. So more clarification about the terms. So Plutonism or volcanism is the geological theory that the igneous rocks forming the Earth were formed from intrusive magmatic activity. So we've talked about this. So the magmatic activity happening beneath the Earth can spew outward, kung erupt upward, causing volcanic eruptions. Okay. Um, and then with the continuing gradual process of weathering and erosion, they are then deposited back into the seabed, formed into the layers of sedimentary rock, and then pushed downwards back into the mantle to be used and then eventually raised again. So this one is actually connected to our lesson on the rock cycle. So the Plutonism or volcanism also proposes that basalt is a solidified molten magma, and it is named after Pluto, the classical ruler of the underworld. That ends our video. I hope you learned something new. Don't forget to subscribe to my channel and like and share this video. Till next time, goodbye.